talked about at the end of class last Thursday. We're just reviewing the different interpretations of the trig functions that we've talked about so far. We've talked about the trig functions as ratios of sides of a triangle. We've talked about the trig functions as coordinates of points on the terminal side of an angle in the Cartesian coordinate system. And didn't I try to get like a 2-minute head start Thursday on this, and that's about as far as I got. That last interpretation of trig functions was just that the sine of theta was the y coordinate over the radius, the cosine of theta was the x coordinate over the radius, and the tangent of theta was the y coordinate over the x coordinate. And on the unit circle, that radius would be 1, because that's the definition of a unit circle, a circle centered at the origin with radius 1. Now, this definition just extends our understanding of trig functions to not only triangles and not only angles in the Cartesian coordinate system, but just trigonometric functions of any real number. And this note right here is important. Sine of 2 means the sine of 2 radians, not the sine of 2 degrees. So the definition of the value of a trig function at any real number, t, is just its value at an angle of t radians. So again, the argument of the trig function is understood to be in radians if you don't have the degree symbol. The definition of the trig functions in terms of unit circle, like I said, we already have the sine of theta being y over the radius, but in the unit circle, the radius is 1. So the sine of t radians, or the sine of the real number t, is just the y coordinate that corresponds to a point on the terminal side of the angle on the unit circle. Cosine of t is just the x coordinate, tangent of t is just the y divided by the x, and then you have your reciprocal functions. So we are finally ready to talk about the unit circle, and this is how we're going to interpret the trig functions for the rest of the semester and all throughout calculus. We're going to be talking about the trig functions as functions of angles on a unit circle. And there's not going to be much memorizing here. There's going to be do it until you just see it in your sleep, see the unit circle in your sleep. Let me see page 363, number 4 and 8, what I wanted to tell you about those two. And then we'll work on our unit circle. I'm not even going to write down number 4. Number 4, you're just asked to find the values of the trigonometric functions at some real number t. And remember, the trig functions at some real number t just means the trig functions of an angle of t radians in the unit circle. So the sine of this angle t would just be the y coordinate, the cosine would be the x coordinate, and the tangent would be the y coordinate divided by the x coordinate. And then you find the 3 reciprocal functions. Nothing exciting about that one. I do want to show you number 8. We're given a point. On the unit circle, let P of t be the point on the unit circle U that corresponds to some angle measurement of t radians. If P of t has the given rectangular coordinates, find, and then there's an A, B, C, and D part. In what quadrant does the terminal side of this angle lie? If x is positive and y is negative, this is a fourth quadrant angle. I don't know exactly where in the fourth quadrant, but somewhere there's an angle from the positive x-axis around to that terminal side that measures t radians. And here's a point on that circle, 7/25, negative 24/25. Now, if we were just supposed to find sine of t, cosine of t, tangent of t, and the other three, gosh, that rhymed, it would be just like number 4. But rather than that, number 8 says find p of t plus pi. And that means t plus pi radians. How many degrees is pi radians? 180 degrees. 360 degrees, the whole circle is 2 pi radians, so half of the circle, or 180 degrees, would be pi radians. So tell me one other thing. If you're here and you're going to go pi radians, is adding going in the clockwise or counterclockwise direction? Yeah, a positive angle is in the counterclockwise direction. So if we started here and went 180 degrees counterclockwise, where would we end up? In the second quadrant. That same angle, but in the second quadrant, what would the point on the unit circle be for that angle? Same coordinates, except for in the second quadrant, x is negative and y is positive. And that's all we're asked to find, just that point. In the B part, we're supposed to find p of t minus pi. And again, if we started with that point on the unit circle that corresponded to t radians, and we went pi radians, or 180 degrees, clockwise, in what quadrant would we end up? Same one, because if you're going 180 degrees, that's halfway around the circle. It doesn't matter which direction you're going, you're going to end up at the same place. And then the C part, p of negative t. Now, I don't know how many degrees it takes to get to this terminal side that corresponds to that point. I know it's between what and what? Between 270 and 360. It's past the vertical y-axis, but not yet back full circle. So it's somewhere between 270 and 360. What would p of negative t mean? Go that same distance, but in a clockwise rather than a counterclockwise direction. Now, an angle in standard position always starts with its initial side on the positive x-axis. So if I went somewhere between 270 degrees and 360 degrees clockwise instead of counterclockwise, in what quadrant would my terminal side be? Yeah, here's going clockwise, here's 90, 180, 270, and then some past that would end up in the first quadrant, where both the x, oh, I didn't mean to write q comma I like that was an ordered pair. I meant to write quadrant 1. Where the x and y would both be positive. And then finally, the D part says find p of negative t minus pi. Well, p of negative t would be that same first quadrant angle, So if I went 180 degrees clockwise from that I said the answer. From that first quadrant angle, in what quadrant would my terminal side be? It'd be in the third quadrant then, where the X and the Y are both negative. So I think this problem is about getting you to recognize two things. Number one, positive angle goes counterclockwise, negative angle goes clockwise, and then again, pi is 180 degrees. So going 180 degrees clockwise or counterclockwise. All right, let's talk about the unit circle. We've been leading up to this ever since fall break. I think in your 5.3 notes, you have this big copy of the unit circle and a small one. Until you get the unit circle just so firmly stuck in your head that you see it in your sleep, I would probably print off a few copies of this and practice filling it out once a day. On the test, you can't bring in a unit circle that you've already filled out, and I'm hoping that you won't have to fill out the complete unit circle to do what you need to do on this test. We'll talk about why you don't need to fill out the complete unit circle later. But if this is the x-axis and this is the y-axis, and this is a point on the unit circle, meaning that radius is 1, then what ordered pair names that point? Yeah, if it's on the x-axis and the radius of that circle is 1, then that's the point 1, 0. That's 0 degrees or 0 radians, or the real number 0. What is the ordered pair that would name this point on the y-axis for a 90-degree angle? Yeah, that is x is, x is 0, y is 1. And that's 90 degrees. Or how many radians would that be? Yeah, a half a pi. If 180 degrees is a whole pi, 90 degrees is a half pi, or we're going to just write it pi over 2 radians. And this 180 degree angle is pi radians. And what's the ordered pair that names that point on the unit circle? Negative 1, 0. And at 270 degrees, what would the radian measure be? Three halves pi, because look, every time we go 90 degrees, we're counting by half pi. So this is 1 half, 2 halves, this is 3 halves pi. And what's the ordered pair that names that point? X is 0, y is negative 1. All right, so far so good. And I know that in the first quadrant, all of my x's and all of my y's are going to be positive. In the second quadrant, I have my negative x's and my positive y's. In my third quadrant, I have the negative x's and the negative y's. And the fourth quadrant, positive x's, negative y's. All right, let's talk about our 45-degree angles. They bisect each quadrant. So if this is 0 degrees and this is 90 degrees, this must be my 45-degree angle here, or how many radians is that? If it's halfway to pi over 2, then it's pi over 4. As a matter of fact, I'm going to go all the way around the unit circle counting by 45 degrees, and then I'm going to come back and count around the unit circle by pi over 4 to have the degree and radian measures of each of those 45-degree angles. All right, look up just a second. If this is 45, 90, what's that? 135. And then another 45 is 180, and another 45 is 225, and another 45 is 270, and another 45 is 315, and another 45 is 360. 360 is the 360 degrees, or 2 pi radians is the same angle as 0 degrees, or, oops, I left out the pi, 0 degrees or 0 radians. Let's go around the circle again, counting by quarter pies. 1/4, 2/4, 2/4 is a half, so far so good. This must be 3/4, 4/4 is a whole pi. This must be 5/4. Another 45 degrees would be 6/4. 6/4 reduces to 3/2. That means I'm on track so far. In the fourth quadrant, my 45-degree angle would be, yeah, here's 4/4, 5/4, 6/4, 7/4. And then another quarter pi would get me to the 2 pi. Now we just have to figure out what these points are. Well, I remember from my 45-degree triangle, let me think about it. For a 45-degree triangle, we used an isosceles right triangle. That was half of an equilateral triangle. The adjacent side was 1. The hypotenuse was, making sure I'm doing this, yeah, square root of 2. Let me think, that was 1. This was, that was 2. That was, well, doggone it, I'm going to have to draw the whole triangle. It was a triangle. This is 1, this is 2, that's square root of 3. It was an equilateral triangle with all sides being 2, and we cut it in half, so that is 1, and then by the Pythagorean theorem, that altitude is square root of 3. So what was the sine of 45 degrees? The opposite over the hypotenuse is square root of 3 over 2. Is that your x-coordinate or your y-coordinate? That's the y. I'm sorry, what? Have I just done, I've just made my 30-60 degree triangle. That's my 30 degree, shoot. Okay. That's my 60 degree. That's my 30 degree. That was the equilateral triangle where this is 2, this is 1, that's square root of 3. My 45 degree angle, this was 1, that was 1, and that's square root of 2. All right. Gosh darn it. I messed that up good. The cosine of 45 degrees. Cosine of 45 degrees would be adjacent over hypotenuse, 1 over square root of 2. For reasons that you'll see in just a minute, I want to go ahead and rationalize that denominator and call it square root of 2 over 2. And then you're right, since that's an equilateral triangle, the sine of 45 degrees is the same thing, square root of 2 over 2. As a matter of fact, at all of these 45-degree angles, the x and the y are both going to be square root of 2 over 2 with the appropriate sign affixed depending on what quadrant I'm in. This would be positive square root of 2 over 2, positive square root of 2 over 2. And my quarter pi in the second quadrant would be negative square root of 2 over 2, positive square root of 2 over 2. My quarter pi in the third quadrant, both the x and the y would be negative. And in the fourth quadrant, my x would be positive and my y would be negative. All right, let's fill in these multiple of 30-degree angles. If this is pi over 2 and 30 degrees is 1/3 of the way to 90 degrees, what's the radian measure of 30 degrees? However, what? It's 1/3 of the way to pi over 2. 1/3 of pi over 2 is pi over 6. So this 30-degree angle is pi over 6. We're going to go around the circle once, counting by multiples of 30 degrees, and then go around the circle again, counting by multiples of pi over 6. All right, there's 30 degrees, 60 degrees, another 30 is 90. So far, so good. Another 30 is 120. Another 30 is 150. Another 30 is 180. So far, so good. Another 30 is 210. Another 30 is 240. Another 40 is 270. So far, so good. Another 30 is 300. Another 30 would be 330. Another 30 is 360, and we're all the way around the circle. All right, we're going to get really good at counting by multiples of 1/6. Look up just a second. Let me show you something. You're going to get good at saying 1/6, 2/6, and reducing 2/6 in your head. 3/6, reducing 3/6 in your head. 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. All right, let's write it down. There's 1/6. So this is 2/6, better known as pi over 3. 3/6 is better known as a half, and we already have it labeled. Another 6 would be 4/6, better known as 2/3 pi radians. That's 4/6. Another 6 would be 5/6 pi. Another 6 would be 6/6 pi, better known as a whole pi on the negative x-axis. All right, another 6, this is 6/6, so 210 must be 7/6. 240 is 8/6. that are known as 4/3 pi. 9/6 reduces to 3/2 pi, so we're still on track. 300 degrees would be 10/6, which reduces to 5/3 pi. And then 330 is 11/6 pi. And 360 would be 12/6 pi, better known as 2 pi. So here's what you're going to get really good at. Going around and around that circle, going 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4 for your quarter pies. And then 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, 12, 6 for your pi over sixes. And all that's left is these ordered pairs at the multiples of 30 degrees, which should be this triangle. What's the cosine of 30 degrees, looking at this angle right here? Adjacent square root of 3, hypotenuse is 2. So the cosine of 30 degrees is square root of 3 over 2. And what about the sine of 30 degrees? Opposite is 1, hypotenuse is 2. So the y coordinate's 1/2. Yes, exactly. Cosine is your x, sine is your y. Now look at your 60-degree angle on that triangle. The cosine of 60 degrees is 1/2. That's your x. And the sine of 60 degrees is opposite over hypotenuse, square root of 3 over 2. I just discovered something huge that's going to help me memorize this so I don't have to draw those triangles. Notice that the only x coordinates on this whole unit circle are 1, and then just a little bit smaller than 1. Square root of 3 over 2 is close to 1. Square root of 4 over 2 would be 1. So this is close to 1. What if I call this square root of 4 over 2? That's 1, right? Square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2. As my x's, or my angle, goes from here to here, my x's are getting closer and closer to 0. X was 1 here, x is 0 there, so my x's are getting smaller as I move through that first quadrant. What's happening to my y's as I move through that first quadrant? The y's are getting larger because the y is 0 here and 1 here. Look at these y values. Square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2, or just 1. These 4 quadrantal angles, it's easy to label. And then just remember, all of your quarter pies are, the x and the y are both square root of 2 over 2 with the appropriate sign affixed. The only 2 points I ever had trouble remembering which was which is the 30 and 60 degree angle. I knew that one of the coordinates was square root of 3 over 2 and one of the coordinates was 1/2. Now I just say square root of 3 over 2. That's much closer to the x being 1. The x is close to 1 at 30 degrees. The y is close to 1 at 60 degrees. If you think about this triangle formed by this point right here, the x would be almost 1. Actually, it would be square root of 3 over 2. And the y, this is not to scale so it doesn't really look like it, but that y is supposed to look like a half. It's halfway up the y-axis. All right, so let's get these other three quadrants labeled. At 120 degrees, that's just as high as the point at 60 degrees. So the y is still square root of 3 over 2. The x is now a half. Only it's negative because we're in the second quadrant. At this 150 degrees, or 5/6 pi, the x is almost back to -1. So the x is negative square root of 3 over 2. The y is a half. At 7/6 pi, what's closer to being 1 or -1, the x or the y? Right here. The x was just -1 here. It's still close to -1. The x is negative square root of 3 over 2. The y is negative a half. That's this point. And then at 240 degrees, or 4/3 pi, is it the x or the y that's closer to being -1? The y is close to being -1. The y is negative square root of 3 over 2. The x is -1/2. Then at 5/3 pi, is it the x or the y that's closer to being -1? The y just was -1 right here, so the y is negative square root of 3 over 2. The x is positive a half at this point. And then at 11/6 pi, the x is almost back to 1. So the x is square root of 3 over 2, and the y is -1/2. I didn't bring my little bitty unit circle in here with me. You have it on your notes, but here's all you really have to write down. Once I give you blank paper on this next test, this test has one page, which I don't let you use your calculator on because you really, really need to know this unit circle. The page that you're actually doing some calculations, once you turn that first page in, you can use your calculator on the second page. But I have had folks spend 20 minutes making a beautiful unit circle at the top of their test. You don't need to, because the trig functions are circular functions. They just repeat as you go throughout the Cartesian coordinate systems. As you move through the quadrants, the ordered pairs just repeat. So all I really have memorized, or just from practice have gotten comfortable using, I would draw me a little 30, 45, and 60 degree angle in the first quadrant. After that, everything's just going to repeat. I might even go ahead and say this is positive, positive, negative, positive, negative, negative, and positive, negative. This is pi over 6 radians, pi over 4 radians, pi over 3 radians. and then label the ordered pairs of those 4 quadrantal angles and those 3 first quadrant angles. Remember that at the quarter pi, the x and y are both square root of 2 over 2. And at pi over 6 and pi over 3, one of the coordinates is a half and the other is square root of 3 over 2. I just need to figure out which is which. At pi over 6, is it the x or the y that's closer to being 1? Your x is close to being 1, so pi over 6 is square root of 3 over 2, 1/2, and pi over 3 is 1/2 square root of 3 over 2. I think that took us less than 60 seconds, and I can use that to answer just about any trig question that you ask me. So that's what I would put down on blank paper if I needed to for the test. I think it's quite possible you won't even have to write that down. You've done so many trig problems. All right, let's see how we're going to use that unit circle. Numbers 9 through 16 are just find the coordinates of the point and the exact values of the trig functions of t whenever possible. We're not even going to write a lot of these down. I just want to show you how to use the unit circle. Number 10 says find the ordered pair corresponding to negative pi. Well, I wish I had something really, really thin here. Negative pi is how many degrees in what direction? Pi is 180 degrees, negative is clockwise. So if I started on the positive x-axis and went 180 degrees clockwise, the ordered pair corresponding to that point on the unit circle would be -1. Actually, I am going to write this down. 10. It could matter because you would have to know that, wait. I'm wanting to say, go ahead and pay attention to it because I can't think of a time or an example where it might mess you up. But if you're going around the unit circle 180 degrees, it's going to be the same distance, clockwise or counterclockwise. You're right about that. I'm just hesitant to say, don't worry about it. That ordered pair corresponding to negative pi radians is -1, 0. So we want to find, how did they write this? Find the coordinates of p and the exact trig functions of t. This is negative pi t radians. So sine of t would be what? This is t equals negative pi. T is the number of radians, or the real number. So sine of that angle would be what? Is it the x or the y? Sine is the y. So sine of t would be 0. Cosine of t would be the x, -1. Tangent t is the y over the x, which would be 0. And from there, you can find cosecant t, secant t, and cotangent t. Cosecant t would be what? Zero is 0 over 1, and the reciprocal of that is undefined. What about secant t? The reciprocal of cosine, reciprocal of -1, is still -1. What about cotangent t? That's the reciprocal of 0 again, which is undefined. I just wanted to write down one part so that you would see if you wrote down the ordered pair corresponding to t radians, then the sine is just the y, the cosine is just the x, and the tangent is the y divided by the x, and then you have the 3 reciprocal functions. For the other ones, I'm not going to write down all 6 trig functions. I just want to make sure that you can extract these ordered pairs. So 10b says t is 6 pi radians. Where would going around the circle 6 pi radians land you? Back on the positive x-axis, because 2 pi would be once around the circle, 4 pi would be twice, 6 pi would be 3 full times around the circle. So the ordered pair is 1, 0. Number 12, let's do the B part. Negative pi over 2 would be how many degrees? Pi over 2 is what? 90 degrees, and then negative is in the 90 degrees just clockwise or counterclockwise? Clockwise. Negative is clockwise. So 90 degrees clockwise would be the same as 3/2 pi. The ordered pair is x is 0, y is -1. And then you could find all 6 trig functions. What about 14b? -7 quarter pies. Just count by your quarter pies in the clockwise direction until you get to 7, and tell me in what quadrant would that be. Here's -1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. So it's in the first quadrant. I know all the quarter pies. The x and the y are both square root of 2 over 2. And in the first quadrant, they're both positive. Um, 9 through 16 just have us practicing quarter pies. 17 through 20 say use formulas for negatives. Let's talk about these formulas for negatives for a second. These you absolutely don't memorize. Think about what this is saying. The sine of -t, that's t radians clockwise, is the opposite of the sine of t radians counterclockwise. Let me think about that for a second. Where's my big unit circle? Here it is. Here's 0 radians. If I go t radians counterclockwise or t radians clockwise, say 30 degrees counterclockwise or 30 degrees clockwise, what stays the same, the X or the Y? The X's stay the same. The Y's are opposites, right? Let's check that out for 60 degrees. 60 degrees counterclockwise or 60 degrees clockwise. I can get it all on here. 60 degrees counterclockwise or clockwise, the X's are the same, the Y's are opposites. That's the same thing that happened at 30 degrees. That's the same thing that happens at 45 degrees. That's why you don't memorize the formulas for negatives. Whether you go clockwise or counterclockwise, cosine, the X coordinate is going to be the same. The Y coordinate is going to be the opposite if you're going clockwise than it would be if you're going counterclockwise. So I don't use those formulas for negatives at all. If you give me number, let's say 18B, that says find the cosine of negative 225 degrees. I'm going to look at my big unit circle or my abbreviated form of it and count by multiples of 400 or multiples of 45 degrees in the clockwise direction. So here's 45, 90, 135, 180, 225 would be in the second quadrant. I know at all the quarter pies or all the multiples of 45 degrees, cosine, well, let me write down the ordered pair first. I know the X and the Y are both square root of 2 over 2. And since that's in the third quadrant, they're both negative. So what does cosine of negative 225 degrees equal? Yeah, the X coordinate. You find the angle, then find the ordered pair, and then extract what you need, either the X or the Y, depending on whether it's sine or cosine, or the Y over the X if it's tangent. All right, we've almost caught up because I think all we lack is some problems that say refer to the graph. We're not going to refer to the graph. We're going to refer to the unit circle because we haven't graphed this yet. And find the exact values of X in the interval from 0 to 4 pi. That means 2 complete revolutions of the unit circle. In 2 complete revolutions of the unit circle, we're going to find the angles where sine is 1. Now, is the sine 1 at on the x-axis or on the y-axis? The y-axis. Sine is 1 right here. And how many times in one revolution of the unit circle is that y-coordinate going to be positive 1? Positive 1. Just once. It's negative 1 down here, but just once is it positive 1. So in 2 revolutions of the unit circle, how many times would sine be 1? Twice. This would be at pi over 2, and then 1/2, 2/2, 3/2, 4/2, back around to 5/2. That's the 2 times in 2 revolutions of the unit circle that sine or the y-coordinate would be positive 1. So number 40, solutions to sine x equals 1 would be at pi over 2, and 5/2 pi. And the only reason we have two answers is the direction said in 2 revolutions of the unit circle. If it said on the interval 0 to 360 degrees or 0 to 720 degrees, then you would answer in degrees. All right, one more. Last one, what about number 42? We're looking for where sine x is negative square root of 2 over 2. Is that going to happen at a multiple, or how can I ask it? I recognize that square root of 2 over 2. It happens at multiples of what? 45 degrees, or in radians, pi over 4s. So I know it's going to be some quarter pi. Where or in how many times in one revolution of the unit circle is the y coordinate negative? Negative square root of 2 over 2. Oh yeah? How many quadrants have negative y values? No. 2 quadrants. In 2 quadrants, there are going to be y values that are negative square root of 2 over 2. So in 2 revolutions of the unit circle, how many solutions are there going to be? 4. I need the 3rd quadrant quarter pi and the 4th quadrant quarter pi. So here we go. 1/4, 2/4, 3/4, 4/4, 5/4, and then 6/4, 7/4. 5/4 and 7/4. Yeah, I started to say then you can, now you can't just say plus pi because that's 190 degrees and you'd end up in the first quadrant. But once you have the 5/4 and the 7/4, if you want coterminal angles, you could keep by counting by fourths if you wanted to, or you could just add 2 pi radians would give you coterminal angles. 5/4 plus 8/4 is 13/4. And 7/4 plus 8/4 is 15/4.